Good morning, everyone. In the previous class, you have learned about scientists who work for classification of elements. In the last class, Dobereiner triads and limitations were discussed. When sets of three elements were arranged into triads by Dobereiner based on the atomic weights, does Dobereiner's triad classify only 9 elements? Yes. Also, his work encouraged other scientists to study elements in better way. In this class, first we see Newland's law of octaves. John Newland was a British chemist. Newland found that when elements were arranged in the ascending order of their atomic weights, they appeared to fall into 7 groups. Each group contained elements with similar chemical properties. Based on these observations, Newland proposed the law of octaves. The law of octaves states that when elements are arranged in the ascending order of their atomic weights, they fall into a pattern in which their properties repeat at regular intervals. Every eighth element starting from a given element resembles in its properties to that of the starting element. Elements with similar chemical properties are to be present along a horizontal row. In Newland's table of elements, if we start with hydrogen, its eighth element is fluorine and next eighth element is chlorine. The properties of hydrogen, fluorine and chlorine are similar. Similarly, if you start at lithium, then eighth element is sodium and next coming eighth is potassium and so on. These elements show similar physical and chemical properties. Was the law of octaves given by Newland correct? Newland's table is not without problems. There are instances of two elements fitted into the same slat. Example, cobalt and nickel. Certain elements totally dissimilar in their properties were fitted into the same group. For example, he arranged cobalt, nickel, platinum and iridium with have different properties compared with halogens in the same row. Newland's periodic table was restricted to only 56 elements and did not leave any place for new elements. Elements that were discovered later could not be fitted into Newland's table in accordance with their properties. Are you familiar with musical notes? In the Indian system of music, there are 7 musical notes in a scale. Sa, Re, Ga, Ma, Pa, Da, Ni. In the West, they use the notations Do, Re, Mi, Fa, Sol, La, Ti. Naturally, there must be some repetitions of notes. Every eighth note is similar to the first one, and it is the first note of the next scale. In musical scale, any note in a key is separated by an interval of 7 notes. This must have made him to force all the elements into this pattern, sometimes without caring about similarities. This is Newland's law of octaves. The more developed periodic table based on atomic weights was given by Mendeleev. Let's learn about his periodic table. Mendeleev arranged the elements known at the time in a chart, in a systematic order in the increasing order of their atomic weights. The modified Mendeleev periodic table, he divided the chart into 8 vertical columns known as groups. It is said that elements in a group have similar properties and elements along periods have different properties. The elements in the first column, for example, reaction with oxygen, to form compounds with the general formula are 2O. For example, lithium, sodium and potassium when react with oxygen and form compounds. Elements of the second column react with oxygen to form compounds with the general formula RO. For example, beryllium, magnesium and calcium. When react with oxygen, they form their compounds. Mendeleev tried to explain the similarities of elements in the same group in terms of their common valency. Based on his observations regarding the properties, a law known as the periodic law was proposed. The law states that the physical and chemical properties of the elements are periodic functions of their atomic weights. Salient features and achievements of the Mendeleev's periodic table: groups and subgroups, periods, predicting the properties of missing elements, correction of atomic weights, anomalous series. Let's learn about them in detail. Groups and subgroups. There are 8 vertical columns in Mendeleev periodic table called as groups. They are represented by Roman numerals 1 to 8. Elements present in a given vertical column, that is group, have similar properties. Each group is divided into 2 subgroups A and B. The elements within any subgroup resemble one another to a great extent. For example, subgroup first A elements called alkali metals like lithium, sodium, potassium, rubidium, cesium resemble each other very much in their properties. The second one is periods. The horizontal row in Mendeleev's periodic table are called periods. There are 7 periods in the table, which are denoted by Arabic numerals or numbers 1 to 7. Elements in a period differ in their properties from one another, unlike groups. Third one, predicting the properties of missing elements. Based on the arrangement of the elements in the table, he predicted that some elements were missing and left blank spaces at the appropriate places in the table. Mendeleev believed that some new elements would be discovered definitely. He predicted the properties of these new additional elements in advance, purely depending on his table. His predicted properties were almost the same as the observed properties of those elements after their discovery. He named those elements by adding the prefix eka. What is eka? Eka is a Sanskrit word for number 1 to the name of the element immediately above each empty space. The predicted properties of elements, namely Eka boron, Eka aluminium and Eka silicon, were almost same as those of scandium, gallium and germanium, which were discovered later. Fourth one, correction of atomic weights. The placement of elements in Mendeleev's periodic table helped in correcting the atomic masses of some elements like beryllium, indium and gold. For example, at the time of Mendeleev, beryllium was given atomic weight is 13.5. Atomic weight is equals to equivalent weight into valency. The equivalent weight of beryllium was found as 4.5 and its valency was thought as 3. Therefore, the atomic weight of beryllium was given as 4.5 into 3 equals to 13.5. With this atomic weight, it had to be placed in a wrong group in the table. He said that its valency should be only 2. Then its atomic weight would be 4.5 into 2 is 9. If atomic weight of beryllium is 9, it would be fit in the second group and its properties would be similar to magnesium, calcium of the second group elements. In the same manner, the atomic weight of indium and gold were corrected. Last one is anomalous series. Some anomalous series of elements like tellurium and iodine were observed in the table. The anomalous series contained elements with more atomic weights like tellurium 127.6 units placed before the element with less atomic weights like iodine 126.9 units. Mendeleev made minor diversions in the order of increasing atomic weights, which resulted in elements being placed in correct groups. Limitations of Mendeleev's periodic table. First one, anomalous pair of elements. Certain elements of highest atomic weights precedes those with lower atomic weights. For example, tellurium atomic weight is 127.6, precedes iodine atomic weight is 126.9. Dissimilar elements placed together. Elements with dissimilar properties were placed in the same group as subgroup A and subgroup B. Chlorine is of 7th A group and manganese is of 7th B. But chlorine is a non-metal, whereas manganese is a metal.